Hello, I'm Eric Snodgrass, and thank you for watching this Monday night, June 12th In-Depth Ag Forecast brought to you by Nutrien Ag Solutions. We start off with satellite data again, and what I want to show you is kind of the new regime that the atmosphere is in, that it has broken away from, that we've been stuck in for about 5 weeks now. And what you're looking at here is a deep low that is over the Great Lakes. Now, we've not been able to put something like that over the Great Lakes in a long time. Now, that low throughout the day today just continues to curl up. It is cut off from the flow, which means through Tuesday into Wednesday, it'll only move to about there. It's going to sit and spin right over the top of Michigan, and around it we're expecting quite a bit of heavy rainfall kind of in this area as it kind of slowly drifts itself into New England, where it's also going to deliver heavy rainfall. Meanwhile, there will be a lingering frontal boundary that will just sit right along this area and stretch back up to the plains here, along which we're going to be watching for strong to severe storms. And in fact, this afternoon you can already see some of the storms popping in the southeast up into the Carolinas. There have been multiple complexes of very large storms that have come through this part of the southern plains, including yesterday some extremely large hail in and around the Dallas-Fort Worth area. And once again, just take a look right here in this part of Colorado. Large thunderstorm complexes putting down just a lot of rainfall. The second trough is actually over the west, and it continues to spin just like this. But what I'm going to watch is these clouds right here. That may not look like much, but see what I just outlined down at the bottom? If you go back and forth today, take a look. That is the beginning of a ridge that's building in this area. It's going to build into Texas, and that's going to be a part of this upcoming pattern. But as it stands, just animating here the rainfall over the last about 12 hours or so. Large complexes of storms, again, these are still moving through today, setting up right down here. Here's the big ones from last night, and watch again in parts of Colorado. Large storm complexes, very heavy rainfall, more hail out of this, and also some straight line wind damage. And that's all just circulating around this deeper trough that's still sitting over parts of the west. And I'm not sure that that trough is going to go anywhere anytime soon. The change is happening throughout Canada, it's happening throughout the Great Lakes and Northeast, and it's certainly happening over Texas. So this is what we're seeing. If we look out there right now at the upper level flow, here's the cutoff low I just mentioned. Notice what's gone. There's no longer any massive ridges that are set up across the Canadian prairie. We're watching this ridge right here evolve and push its way towards Texas. I do expect deeper troughs to continue to sit into the western United States. The model's been very clear on that. There's a lot of meteorological evidence for that, but this ridge as it builds in is going to be a critical new piece to be talking about as we just progress into the middle and late part of this week and then into next week as well. Still, the Bermuda High, nowhere to be found. It would be very, very strong if it sat right in through this area, but we don't see that right now. In fact, we've got two low pressure centers on either side. You can make an argument that it's still sitting over the UK, or maybe part of it's stretched down here in the tropics, but either way, it is split and broke up and not in its normal configuration. So thinking about that, let's just get to some near-term details. And this afternoon, I'm recording this about 4 o'clock. Flood watches and warnings. We have the severe thunderstorm watches over here, tornado watch, severe thunderstorm watch, and a heat advisory. And that's key to where this ridge is going to be building in. But keeping on the severe weather theme, this is for the rest of the day today on Monday, if you get a chance to watch the video Monday night. As we go into the day on Tuesday, not much of a change overall in the risk area that was put out this morning from the SPC through here, again on that lingering frontal boundary. And then as we get into Wednesday, same scenario here. We're expecting very heavy rain with some of these storms as well. Now, a quick update on the near-term models. This is the 12Z run from the NAM. And I want you to keep an eye first right up here, because as we go through the day on Tuesday, so this is Tuesday morning, Tuesday midday, into Tuesday evening, the southward extent of this rain could clip some of those areas that were missed over the weekend. This is not going to hit Iowa, but could hit parts of southern Wisconsin, northern Illinois, maybe eastern Illinois, the northern half of Indiana, and a big part here of Ohio getting into Pennsylvania. And that low, once we go through Tuesday night into Wednesday, begins to migrate into New England, where it's also going to bring in some colder air and much, much needed precipitation. Now, meanwhile, while all of that was going on, take a look at this boundary right in through here. You just can see complexes of storms rolling along that boundary, large ones in through here as we go into the overnight hours tonight and tomorrow morning, and then again tomorrow afternoon sitting in this same area. And that's because sitting underneath all of this, if we just go down to the low levels, there's this nice little pump of moisture coming in through here, and there's convergence along this boundary. So the flow coming in like this, and right in between the two, that's where we're getting the kind of the squeeze in the atmosphere. There's frontogenesis going on there that's going to force the air to rise. So if we go ahead and use the high-res NAM to add this up. Now remember, don't look at this and try to assess the numbers. In fact, I purposely make the numbers really small over here because I want you to look at the pattern. But this is what we see accumulating from the high-res NAM playing out here until late in the day on Wednesday. So I'll be watching carefully the areas to fill in that were missed this weekend and the severe storms to rip through this area, producing some locally heavy rain, the storms up the Front Range and all throughout the Intermountain West with this particular setup. Okay, bigger picture things. This is something we just keep coming back to in every discussion, right? We started on May the 10th because that was when the pattern kind of got itself stuck, and it was there all the way till June the 10th. So there's 4 solid weeks of this where we saw ridges that just started off over the eastern part of Canada, moved to the western part of Canada, came back, and then now are sitting back over here again. So that's 4 times traversing Canada. What this ended up doing was giving us this high pressure sitting over the Great Lakes, resulting in very dry conditions right in through here. We had anomalously easterly flow, which ran up over the mountains. We were drier in parts of the Pacific Northwest, but quite cloudy, quite stormy throughout much of the rest of the western United States. Some places in through here have had historic flooding, and unfortunately that broke, about a 20-month-long drought in this area with some incredibly heavy rain. So we went from kind of, famine to feast in a very, very short amount of time. Now, one other interesting consequence to the pattern we've been in is to look at cumulative downward solar flux. Now, this is just basically showing you where there's either a surplus of sunshine getting to the surface or a deficit. So basically, it's a metric on clouds. And you just notice those drier areas, I'll kind of put some arrows around them here. These areas have really shown up with a lot of abundant sunshine, whereas we've been extremely cloudy throughout the Front Range into Texas, over the southeast, and then a very, very persistent stratocumulus cloud layer. This is a low cloud deck in the atmosphere that's sitting off the California coast. And this is something we're going to have to come back and touch on in just a few moments. But with all of this abundant sunshine, and when the heat starts to build in, I've been showing this in the morning reports, you can see that we are anywhere between 150 and up to 300 GDDs ahead of normal. So we would consider this to be up to 2.5 weeks ahead of average on the accumulation of heat. But over California, through the Four Corners, Texas, Oklahoma, parts of the deep south here getting over into the southeast up to the mid-Atlantic, this is where we're behind. And just to say this one last time, this is why we've had such stagnant flow across North America. It's been warmer than normal north and cooler than normal south. There's no strong poleward temperature gradient, nothing to drive the upper level winds through what we call the thermal wind relationship. All right, what this all resulted in is this triple ridge forming. Now, I am terrified of this pattern if it is July. It's where we end up getting one ridge here, a second ridge in Canada, and a third ridge, the Bermuda High, way over here south of Greenland, south of Iceland, almost touching, Spain or the UK. And of course, you heard me mention this morning, but the military parades in the UK over the weekend, well, it was the Bermuda High that brought in that heat. But remember, heat is relative, right? So for them to get up to 30 degrees C, that's 86 Fahrenheit, that would not be hot for Arizona. But you just understand the differences here given the geography. So the flow has done this. It's come around and died here and kind of picked back up there, but very stagnant and weak flow in the middle part of the United States and Canada. When this was happening, the MJO spent a lot of time right over here in phase 7 with a lot of subsidence in the atmosphere in the Indian Ocean. We spent most of May with MJO living in phase 7. And historically, that actually leads to more subsidence where you see it over in this area. And subsidence represents high pressure and drier conditions. But here was the real kicker. This is the anomalous jet stream level wind flow. So around one ridge, see the flow there, around another ridge, see it there, and the other ridge here. So everywhere that I drew these arrows coming out of the east, that is robbing westward momentum, which normally the atmosphere has westward momentum in this direction. So when I tell you the pattern is stagnant, it was actually going against the grain, blocking the systems up, preventing them from advecting or moving downstream. Now, since we've gotten past this first 10 days of June, this one is gone. And we're going to watch what happens here and what happens here over the coming weeks. That's what the other pieces of the flow that need to kind of change, that's where they currently live. All right. Now, thinking about all of that, we know that the Great Basin has been by far the driest. Where did I have that a few moments ago? Right here. So, there. The Great Basin, the Great Lakes Basin, not the Great Basin. The Great Lakes Basin has been extremely dry, including much of the Mississippi Valley, the Tennessee Valley, Ohio Valley, and New England. All right. So just thinking about that, I went out to one of my favorite sites. It's called Climate at a Glance. I chose a regional time series for the Great Lakes Basin from 1970 to 2022, because that's all the data we've got in here for June. And I wanted to know what made things wet. So I ranked them based upon wettest years, and I just plucked off these really, really wet years where we hit between 4 and 6 inches of rainfall in the month of June. And what you end up finding is this. There's a few things I want to discuss with you. The first thing I want to think about is this. Warm water here. I'm going to come back to that in a few seconds. All right. There's no strong El Nino or La Nina. So I know you're going, wait a minute, I see cooler water there. No. There's still no strong signal. This is the signal I want to think about. And I want to think about what's going on in the Atlantic because there was a bit of a cooler signal here and here. Now keep that in the back of your mind for a moment, because the next thing I want to show you is what the jet stream did in those years. You see, there was a trough in the Gulf of Alaska, a ridge right here sitting over the west, and a trough over the Hudson Bay. So what did the flow do? It came over the top and dove down like this. Now that is northwest flow in June, and that is producing a lot of storms that come into this area. It helps when you put a big subtropical ridge there. That's the Bermuda High that pumps the moisture into all of this. So if the Great Lakes were going to cure their drought in June, you got to have a trough here, a trough there. It's got to be super hot in California in a big ridge over Cape Hatteras called the Bermuda High. That's it. That's what those wet ones did. Now, it also helps if you get the MJO to go back to phase 3. Not phase 7, but phase 3. When that occurs, it shifts the whole pattern across the northern hemisphere to produce better rising motion. And phase 3 historically in June, when there's a little El Nino, tends to do this. There's the ridge here, okay? So what we end up getting is troughing somewhere in this vicinity, a ridge over the west, flow comes through, and that ends up giving us that northwest flow with the pump right there of moisture coming out of the Gulf. So that's another component to this. So it's not a perfect match, but MJO phase 3 would be a really nice touch to all of this. But again, I'm just thinking a lot about this warmer water that historically sits here in these very wet years for the Great Lakes Basin. We do not have that right now, and that's an issue. So I put this in my report this morning, and I want to highlight what I think is the most important part of this forecast. Right here in the middle part of North America, I wrote, each of these things I've labeled is competing for the flow, to dominate the flow across North America. Now, this here is what we call the negative phase of the Pacific meridional mode. We're going to talk about that in a second. This warm water here to here is called the positive phase of the Atlantic meridional mode. We can start to blame the displacement of the Bermuda High on that. It is possible that this cooler water may be driven by excess cloud cover here. Remember we were showing that earlier? Could be helping to promote troughs over the west rather than ridges. But we still have a developing El Nino event. And that developing El Nino event should start to set up some sort of split flow that would do something like this. But none of these things is winning over any of the others. And we've asked, when is El Nino going to take over? Or are we going to see these smaller players, plus the MJO, or maybe even something going on in the Indian Ocean affecting this pattern as we go forward? So I want to tell you about this thing called the negative phase of the Pacific meridional mode. A lot of folks like to put this all in one big pattern called the PDO, the Pacific Decadal Oscillation, where it's cold all through this region and sometimes even back all the way to Japan. We don't have that. We just have this Pacific meridional mode setting up right now. And I want to let you know something. When you look back to 1950, in the month of May, it is currently sitting at an index value of -5. That's very much on the negative side of the distribution, okay? So please keep this in mind as you think about the overall position of this. Now, what I want to show you is what in the world that means. But first, in the Atlantic, if you remember, it's very warm. We have the positive phase of the Atlantic meridional mode. And we are currently sitting on this side of the distribution, so very much in the positive side. So we're comparing the cold water here to the warm water there, and what does it mean? So here we go. These maps I'm about to show you are going to give us an idea about what the Atlantic meridional mode versus the Pacific meridional mode historically correlates with in June, July, and August. So let's blow this up. Actually, let's go June and July only. Now, the AAM is positive right now. And if the AAM is positive, everywhere that you see warm colors, we would see wetter conditions. So here and here. It would tend to be drier in the southwest or along the east coast. So the AAM, which is competing for space in North America, says wet here. Now, what about the PDO? The Pacific meridional mode. Let's flip that over, click Create Plot, and now this is what you get. Now we have a negative Pacific meridional mode, which means these warm colors here mean drier. Same thing for here. So the Pacific Northwest is wetter. The desert Southwest is wetter, but dry along this whole area. So when I tell you they're competing, this is the historical competition I'm talking about. But we're not done yet, because I also told you, if I can go back and find it, look, we have a developing El Nino. And if we just look historically and say, well, compare this now to the MEI, the multivariate ENSO index, this is what you get. So we right now have a positive multivariate ENSO index, and therefore the warmer colors, which are a lot of places here, tend to be a wetter forecast for June and July. This is why so many of us are looking at all these factors and saying it's kind of like the atmosphere is ganging up, like 2 or 3 against 1. The one remaining thing, I'm so sorry, is this guy right here. Now, the Bermuda high isn't helping. If it could come back, that would be a major, major boom to this pattern and really fire it up to start to deliver, this moisture into place. So maybe it's 3-2. And that's what's really just competing for the overall space across the midsection of the United States into the Great Lakes Basin. So thinking about that, I want to now take you just to the latest updates we've got from these models. I showed this morning in the report that goes out via email. Remember, that only goes out once a week now. But they have continued to anchor drier conditions in and around the Great Lakes. And you say, why? Well, the pattern is not there to revive, especially the upper Midwest, to just bring in tremendous amounts of moisture. The competition of each of these factors is actually driving more of a wetter pattern in the Northwest, and then probably around the ridge that's going to be sitting right in through here. That means the Mid-South into the Southeast is going to be wet. Let's compare this now to the newest update from the CFSV2. The end of June to the beginning of July, they've got a corridor that's very stormy in through here, but they're drier in the same spot. The newest model run, though, for July the 3rd through July the 9th did go over drier in the eastern Corn Belt up to the Appalachian Mountains. But this is just one kind of anomalous run that did that, and it doesn't line up with the other models very well, like the the CPC. Now, if we go look at what the European model is showing, this is the week 3 precipitation anomalies. It's a bit drier in this corridor, but it's not showing strongly dry anomalies on either side. And if we now go and look at the week 4 forecast, which gets you up to here, notice that it's actually stormy in this area and no real strong dry signals outside of that. Now, so the ECMWF has still got some life in it that suggests we really start rocking storms across, let's kind of outline an area in through here as we go forward. But the problem is these models producing this particular corridor of storms suggest some ridging events that are going on here. That's one possibility. And the second is maybe some northwest flow that helps it out. But I am so low in my confidence right now after watching the busts we saw in last week's weather forecasts that I'm just going to present the evidence but have to keep investigating it myself, all right? I do want to show you this. This was the forecast from May the 10th through June the 10th, okay? May 10th through June 10th. Did the model pick up on this? Oh yeah, it got this. Did it pick up on the wet conditions in Montana? No. Did it pick up on the stormy conditions in through here? It didn't. Did it get this right? No, we were actually quite stormy in this part of Kansas, although just bone dry right here in this part of Nebraska, Then notice where we've been the driest, it didn't necessarily pick up on that being the strongest signal. But I'll be honest with you, if you want to know the technique to looking at these maps, look at them, look at their forecast, and just blur your eyes a little bit. It's going to give you the gist of the pattern. It's not going to give you the perfect scenario. So let's go have a look at it again. This is the latest run. I want to look at a 30-day outlook, but I want to stretch this out to grab, let's just do the first month after the solstice. The model backed off in the extent of the dryness here. It's kept this whole corridor wet, but it's backed off in the extent of the dryness in this area. Now, that doesn't mean we still can't have drought developing. It's just less dry, okay? So that's a quick summary of your models. Now, if we come back to the near-term issues with all of this, the last 30 days, which is shown here, kind of paint this picture. So there are some very dry corridors in this 30-day pattern, considering all of this in much of the lower Mississippi Basin, while there's been record rain in this region. So just in the back of our heads, we know that this is what we got out of the forecast that, if I just go back to it for you very quickly, on May 11th, looked something like that. All right? So compared to what was observed versus what was forecast, this is what you've got. Now, quick bit on the near term. What I'm watching right now, take this off here, is this shortwave right here. You see what this pattern's up to? Ridge. This trough is exiting. If this ridge builds in and this shortwave comes over the top of this flow and comes right across the Midwest, it could be a catalyst for some change. Now, I've been watching it carefully. Let me show you where it's coming through. So this is a vorticity map, right? We're just looking for anything that can trigger storms. Through Wednesday, all the triggers are down here. There's the low that's exiting. Here's the trough that comes in and helps put out the fires into British Columbia and Alberta. But then as we play this forward, by Friday into Saturday, it doesn't look like much, but there's a shortwave right here. And that shortwave is going to try to cut through right at this point, bringing in another chance for some showers and storms, some of which could be severe. This is Saturday into Sunday time frame. At that same time, a deeper trough comes into the northwest and makes some very, cooler and rainy weather for the Pacific Northwest out of this pattern too. But what I'm concerned about is what happens after this. Deep trough comes into the west. Love it. I like seeing that. That's just going to help excite the flow. But by the 20th or maybe the 21st, where will the storms be? If the model's got this right, there will be an axis of heat here and therefore a big ridge in the low levels of the atmosphere. But storms will just fire and try to punch into that ridge, hoping to get through it. Now that's the simulation done by the European model out that far. That axis right there is what I'm going to be watching. This is what the GFS thinks for the same time. Have you noticed the GFS has consistently been the wetter model? Well, it's that way again. European versus GFS. Look at this low right here. See the closed contour? That's where it is in the GFS on Tuesday the 22nd. European, it's over here like on Cape Cod. And if it's there, boy, that's going to be bringing in better chances of rain. This trough here will bring in better chances of rain. The ridge sits here, so over the top, there's no massive ridge to punch through here. It just delivers the moisture. The GFS is really, really wet, and it's been wet for a while, but it's not verifying very well. So let me show you what happens out of this. Let's do 7 days at a time here. The newest update from the WPC. There's the rain coming into parts of Alberta, British Columbia, putting out the fires hopefully. More storms early this week here and along the Front Range. This is our severe weather corridor right in through here. Potential in parts of Alabama and Georgia for grabbing 3 to 5 inches of rain. The system coming through this weekend is what's brought up the precipitation totals here. Plus, remember, we're going to let this low exit slowly, bringing some wraparound tomorrow on Tuesday into Wednesday into this area. So New England gets a good soaking out of this. That's the WPC. This is the European model. So here we go. We've talked about this part. Here we are into Thursday. Now remember, much of this area, nothing all the way through Thursday. But then as we get into Friday, there's the shortwave. Do you see it coming out of South Dakota and Nebraska into Iowa and possibly into Illinois? That's the wave we're going to be watching coming through. It's going to do its best rains here, but it's going to have a difficult time getting over the larger ridge that's going to try to develop in that part of the country after this. So you see, if I take you all the way out to day 10, notice the last bit of rain comes in and stops right there and doesn't get into this area because the ECMWF leaves a 700 millibar ridge in this place. Now, I'm going to do some comparison though, so let's take it back to 1 week and flip this over to the ECMWF. The GFS, forgive me. Same look in the near term. More generous with the rain coming through in the weekend event here, which needs this rain. And then here comes the next wave. Notice how it tries to make it drier in parts of Kansas or central Iowa. But if you looked at the next run of this, it would flip-flop again and again and again. And by the way, it's still trying to produce a big hurricane right here, but it's always 12 to 15 days away. So let's take you back to where it's the 1 week outlook. There it is. And here's the difference in the models. Everywhere in these colors is where the GFS is wetter by this many inches, and this is where the European model is wet by this many inches. I wouldn't trust either of these models beyond 5 days. That's the end of it. A single operational run, don't trust it beyond 5 days. So what we do is we start to look for the probabilities. And what has changed from this morning's run is you go out there 10 days, this area has continued to show up wetter in the European model. But that's partly because the flow's coming in, and we've got this little saddle point, a ridge that's going to be here at the second waves next week that are going to keep this area drier. Certainly this next week is extremely stormy down here, a lot of severe weather, and with the low that's exiting New England, you're wet here. Still wet up the Front Range and very wet in this part of British Columbia, Alberta, Saskatchewan. Okay, but let's do this. Let's compare to the GFS Ensemble. There it is. Notice how much wetter the GFS Ensemble once again is for that 10-day time period. Let's actually come back to the European Ensemble. There you go. And now let's look at the dry spots. Who's getting less than a ½ inch? So now we've kind of focused this area back into the upper Midwest, into this part of Ontario. And as the ridge builds in down here, that's where we're expecting to see some drier weather. So to show you all of this, this is at the end of 1 week. This is the small ridge axis I'm telling you about that I'm concerned that we won't be able to push through. But going from next Monday into Tuesday, Wednesday, and Thursday. Do you notice this though? There is a ridge here, but the flow, the isobars, the isoheights are tighter. That is a good signal. That is the signal that we could get some storms in through here. That aligns well with the positive phase of the Atlantic meridional mode. That aligns well with the development of El Nino. That does not align well with what's going on with the Pacific meridional. See what we're doing? We're stitching all these things together, trying to make a story out of it. But I'm going to show you the week 2 pattern another way. This is a week 1, day 10, day 14 outlook of temperatures and precipitation. And the models keep trying to do this. Now, if I can blow that up again, there we go. These colors are on the dry side, and these colors are on the wet. As the ridge builds into Texas, about 10 days out, the models are really becoming aggressive on developing a stormy corridor over the top of it. We call these ridge runners. That's what I'm watching out for. That would fit with some of the pieces that are moving in the atmosphere. If we had a Bermuda high here, and then we also had a ridge there, oh, we'd be in business for big-time storms in this area. But as it stands, it's not 0 chances of rainfall. It will be stormy inside of that area. Lastly, are we really starting to open the Gulf back up? Well, here's that animation starting next Friday, or this Friday, into the weekend. Going into next week, we once again see the models trying to open up a corridor in through here where they're at least having a good shot at bringing in 1.5 inches of liquid in the atmosphere to be precipitated out. That's what we want to see. Get that Gulf open and start to use its moisture to make some storms. It is not the wide open Gulf that we can see where this moisture would get all the way up into the northern plains and the Great Lakes, but it's not nothing, and that's what I want to keep honing in on. How about the temperatures? Well, 5-day sliding window of average temperature anomalies from the 12Z run today. Just same story as this morning. We do start to see heat, a lot of it, triple-digit heat coming into south central Texas. That's where the ridge is. But the trough going over this, cool, cloudy, stormy. And what we're going to watch is that flow to come over the middle and come down here, which means we don't break away to warm in this area through the next 10 days either. But from day 10 to day 15, that ridge begins to really dominate this particular spot, and we're going to start to really pull in better chances for some storms in that area. All right, what's the last bit of this? Well, let me shrink this up so I can tell you what I'm concerned about. Remember all this business about the AAM? Well, you historically correlate, because I'm telling you the Bermuda high is everything, you historically correlate sea level pressure patterns with the AAM. This is what you get. When the Atlantic meridional mode is positive, there's an inverse relationship with pressure here, which means this is something we're going to have to watch out for in terms of a lot of low pressure in this area as we go into June and July. And that's what still got me concerned about this upcoming hurricane season. But the bad news is that I don't see anything coming into the mix that's going to make the Bermuda high just come live back in this particular region. And that's the missing component that we've got to see evolve and go forward. So one last thing here, and I'll wrap this up. This was that new June, July, August outlook from the European model. It is still giving us these signals of an early start to the hurricane season, but it's still got drier air anchored around the Great Lakes and a lack of southwestern monsoonal flow. Will these areas of storms be able to advance up into the Corn Belt and start to relieve some of the drought? There are question marks. If the negative PMM does not exert its influence, but El Nino does, and if the positive AAM keeps things going, maybe, yeah, we could look at a better outlook for the rest of June into early July. But at this point, I think too much of this kind of bounces on a knife's edge for a lot of folks. And each one of these systems is going to be critical to keep adding up to see what the moisture looks like as it comes through. And I'll just do my best to keep you informed about it. So I really appreciate all of you that sit with me in these long videos just to kind of learn together and to watch the pattern. And we'll just try to stay on top of it together. Thank you.